Hello, welcome back to the channel. This video, I'm going to focus on IGCSE Physics, paper 6. So the paper that I'm going to discuss is October-November 2023, paper 61. First question. A student determines the weight of a meter ruler using a balancing method. Fig 1.1 shows the setup. A. The student places the meter ruler on the pivot. She places a load, P, on the meter ruler at 90 cm mark. She adjusts the position of the meter ruler on the pivot so that the meter ruler is as near as possible to being balanced. The ruler balances with the pivot at the 75 cm mark. Calculate the distance A from the 90 cm mark to the pivot. Record the value of A in the first row of table 1.1. So I use my own cm rule to do my measurement from one end of the arrow to the other end of the arrow. So the answer that I got for A is 15 cm. But hey, since I'm using a cm rule, I have to look at the sensitivity of my CM rule, which is the smallest division on my CM rule. The smallest division on the CM rule is 0.1 cm. So I have to record my reading by following the decimal points of the sensitivity of my CM rule. So I have to put it in terms of 1 decimal point. B, she records in table 1.1 the distance B from the pivot to the 0.0 cm end of the meter ruler. She repeats the procedure, placing the load P at the 85 cm mark, 80 cm mark, 75 cm mark, and 70 cm mark. She records the values of A and B in table 1.1. Plot a graph of A/cm, that's the unit of A, on the y-axis against B/cm on x-axis, and state the y-axis at A equals 0.0 cm. That also means that you have to start your y-axis at 0 cm and start the axis at a suitable value for your results and draw the best fit line. So this is a graph given. So for your information, you need to make sure that your points, your readings are scattering at least half of the graph paper. Since they already told us that y-axis need to be started with 0 cm, so I start with 0, but my x-axis, I would like to start with 60 cm and ending at 76 cm. But that is not just it. I have to label my x-axis and my y-axis with the appropriate units. So this is it. Now, all the points are being plotted here. I have 1, 2, 3, 4, 5 points all together, and I draw my best fit line. Just forget about this triangle first because it is related to part C. Part C, you are asked to determine the gradient G of the graph. Show clearly on the graph how you obtained the necessary information. See this? This is the one that you need to show on the graph. That's also the reason why I draw my triangle. So the triangle that you draw is for the examiner to see whether the calculation of your gradient is accurate or inaccurate, because that's a rule of how you calculate the gradient. You have to make sure that the triangle, the right angle triangle that you drew on your graph must occupy at least half of the straight line, half of the best fit line that you drew. I maximize it. So these are my 2 points, x1 and y1, and x2 and y2. So my gradient is equal to 15.6 minus 5.8 divided by 76 minus 60, and I got 0.613 as my answer. So I'm going to fill in the blank here. This is 0.613. D, the weight W of the meter ruler is numerically equal to 2G. Calculate the weight W of the meter ruler. Since they have already they told you that the weight is equal to 2 times the gradient. I just use the value of my gradient, 613 times 2. That's the weight value that I got. The 1.23 Newton, that's my weight. E suggests one practical reason why it is difficult to obtain accurate readings for A and for B. So I want to refer you back to the diagram. So this is a diagram. If you face difficulties in giving the reason of why it is so difficult to obtain the accurate reading for A and B, you have to go back to the diagram and see how A and B are being measured. So especially A, you could see that A must be measured from the center of B to the pivot. But hey, P is a load. Load is an opaque material, so it is not easy to see the reading below P. So my reason is the mass block the scale, or the load P actually blocking the scale on the meter rule, because we are not sure whether the load is being placed exactly at 90 cm. And it is also, you might want to give one of the reasons as difficult in balancing the meter rule. So it is hard to make sure that meter rule is balanced, because maybe one of the main reason is because the meter rule itself is not uniform. F, using only the apparatus provided for the experiment, explain briefly how you would determine the position of the center of mass of the meter ruler. So center of mass is actually a point in which the whole mass of the meter rule seem to act. So my reason is because, okay, well, I would say that I find the balance point of the meter rule by balancing it on the pivot. It doesn't mean that it has to be balanced at exactly 50 cm. So sometimes the meter rule, some part of the meter rule is being worn out, so it would not be balanced at exactly 50 cm, maybe 49.8, maybe 48.9, etc. So I need to check the balance point first, and by making sure that I have two rulers here, or just one ruler is enough, I make sure that I measure the two heights of the meter rule at two ends, and make sure that the two heights that I measured by using another meter rule are the same. So this is, if you wonder what I was talking about, so I have a meter rule here, and this is a pivot, this is a ground, and I just make sure that the height here is equal to the height here. H1 is equal to H2. So if you find it difficult to write down the point, so you might want to draw a diagram, and you could ask the examiner to refer to the diagram as shown. Not a problem. Question number 2, a student investigates the resistance of a resistant wire. Fig 2.1 shows the circuit that he uses. A, the student places a sliding contact C at a distance L equals 20 cm from B. He measures the potential difference PdV across the length L of the resistance wire. He measures the current I in the circuit. The meters are shown in figure 2.2 and fig 2.3. First part, write down the current I shown on the student's ammeter. So this is the ammeter. So you have to look at this value over here, because the unit of current is ampere. So the reading is actually 0. This is 0.7 here, 7274, and 0.76 is the answer. So my answer is 0.76 ampere. That's together with the unit. Second part, record the potential difference V on students' voltmeter in the first row of table 2.1. So when we are asked to do our records here, so this is the voltmeter reading, which is equal to, this is 1, so this is 0.1, 0.2, 0.3, 0.4, and 0.5 is here. So my reading is 0.5 volt. So this is 0.5 volt. Third part, calculate and record in table 2.1 the resistance R of 20 cm of the resistant wire. Use the equation R is equal to V over I. Since we have V value and the I value, the R would be equal to 0.5 over 0.76. And I make sure that I put my answer, my value of R in terms of two significant figures, because the R for 60 cm and R for 100 cm are both recorded in two significant figures. So my answer is 0.66 ohm. 0.66 is my answer. And part 4, calculate and record in the first row of table 2.1 R over L for length equal to 20 cm. So my R is 0.66 divided by 20. Since R over L for 60 and 100 cm are both recorded in two significant figures, my answer for R over L for 20 cm, I'm going to put it in terms of two significant figures as well. So 0.33 is my answer. And complete the column headings in table 2.1. Column headings means the title of your table. So you have to denote your table together with the correct symbol and their appropriate units. So length is measured in cm, V is measured in volt, R is measured in ohm, R over L, that is ohm over cm. B, the student repeats the procedure using L equals to 60 cm and L equals 100 cm. The readings and results are shown in table 2.1. Look carefully at the values of R over L in table 2.1. First, write a conclusion about the relationship between R and L. So when I look at all the values of R over L for 20 cm, 60 cm and 100 cm, I don't see there's very big difference, because the difference between all the readings are only 0.02. Oh, this is 0.0. This is, okay, I wrote it wrongly here. It is supposed to be 0.033. 0.033 here. So the difference is only 0.002, which is very, very small. I would say that my conclusion would be when L increases from 20 cm to 60 cm to 100 cm, R over L is still equal to constant. So justify your conclusion by reference to your result. So they ask you, why do you say that R over L is constant? My reason is because the difference between the R over L readings are only 0.002 ohm per meter, which is still within the limit of my experimental accuracy. C, use the values in table 2.1 to estimate the resistance R2 of 2 meter of the resistant wire. You have to show your working. So I will show my working here. Since I say that all the R over L values are constant, R over L, I use the value that is most repeated, which is equals to 0.033. Length is equal to 2 meter, equals to 0.033. Cross multiplication, I get 0.033 times 2, and my answer is 6.6 ohm. So 6.6 ohm is the answer. Question number 3, a student investigates the magnification of the image produced by a lens. Fig 3.1 shows the setup. On Fig 3.2, measure the height H0 of the illuminated object. All you need to do is to measure it using your cm rule, and then you put it on the paper and you just measure it, and the value of H0 is 1.5 cm. Make sure that you put your final readings of H0 in terms of 1 decimal point, because the sensitivity of your meter rule or your cm rule is 0.1 cm. B, figure 3.1 is drawn 1/10 scale. On Fig 3.1, measure the distance U. So the distance U that I got was 2.0 cm. Second part, the actual distance, object distance U is 20 cm. The student places a lens at a distance U equals 20 cm from the illuminated object. he moves the screen slowly until a clearly focused image is formed on the screen. He measures the distance v between the center of the lens and the screen. On Fig 3.1, the distance is represented to scale by the distance v. Use Fig 3.1 to determine the actual distance of v between the center of the lens and the screen and show your working. So the v that I got, I measured, was 8 cm. All you need to do is take the 8 cm times 10 because the scale is 1/10 of the actual value. To find the actual value, you just times 10. So it is equal to 80 cm. So my v is equal to 80 cm. Third, calculate and record in table 3.1 the magnification m using the equation m is equal to v over u. Where is m? M is here, which is equal to v over u. Now I fill in the blank for my v first, which is 80 cm. My magnification here would be 80 divided 20, so I got 4 as my answer. But I put it in terms of 3 significant figures because my m for 30 u equals 30 cm is 3 significant figures. And calculate and record in table 3.1 as well the ratio hi over h naught. So hi is 5.9, h naught is the one that you measured earlier, which is this one, 1.5. So divide 1.5 and you're supposed to get 3.9. There's no unit for h1 over h naught because the units will be cancelled off. See, the student repeats the procedure using u equals 30 cm. The readings and results are shown in table 3.1. Another student suggests that the magnification m is equal to the ratio hi over h naught. First part of C, state whether the results agree with the suggestion. Justify your statement by reference to the result. So my statement is yes, agree. Why? Justification is because the difference between the m and h1, the ratio of hi over h naught is only 0.1 for u equal to 20 cm and 0.04 for u equals 30 cm. So I think that the differences are still within the limit of my experimental accuracy. So that's my reason. Second part suggests how you would continue to use the same apparatus to test the suggestion that the magnification m is equal to the ratio hi over h naught. I said that maybe I could repeat the experiment with different values of object distance, like I suggested as a 40 cm, 50 cm, 60 cm, and 70 cm. And then I compared the value of magnification and hi over h naught values. Question number 4, a student investigates the time taken for water to evaporate to dryness when heated from above. Fig 4.1 shows the setup. The power of the heater is constant. The following is also available: supply of water at room temperature, meter ruler. So we have to plan an experiment to investigate how one factor affects the time taken for the water to evaporate. You do not need to write about safety precaution. Wow, that is good news. But you should state any additional apparatus required and explain briefly how you would do the investigation, state the key variables that you will keep constant, draw a table. Normally we just draw one table with column headings to show how you would display your readings, and you are not required to enter any readings in the table because you are just the planner. And explain how you would use your readings to reach a conclusion. So I would just follow whatever they ask me to do. But first of all, I would want to draw a diagram. The benefits of drawing a diagram is that we could plan our experiment in a more detailed manner, so we won't miss out any important points. So I would say that I don't have to cancel here and cancel there, and suddenly I think of another point that I should have put it on. No, I prefer to draw a diagram, and I do suggest you to draw a diagram as well so that you can plan your experiment in a better manner. So I don't just draw, I need to label. my diagram as well. So all these are being labeled here. And I use a rheostat here as a safety precaution, but don't worry, we are not supposed to write down the safety precaution. So the additional apparatus that I use are thermometer to measure the temperature, stopwatch to measure the time taken for evaporation to occur, and measuring cylinder to measure the volume of the water. So the methods are, since I draw the diagram, I would want the examiner to refer to my labeled diagram. Set up the apparatus as shown in diagram. And I just give a value to show that, so that the experiment can be planned in a better way. I said that I only use 20 cm cube of water to be measured by measuring cylinder, and I pour into a shallow dish. The initial temperature is recorded by my thermometer. The height of the infrared heater and the surface of the water is measured by a meter rule. Power supply, I set it to 2 volt and I switch it on. And my stopwatch is started at the same time when the power supply is being switched on. After that, I just stop my stopwatch when the shallow dish is dried up. And the time taken for this 20 cm cube of water to be evaporated, I record it. An experiment I have to repeat with different heights. So that's all for my methods. And of course, I need to write down the variables to be kept constant during the experiment. So I make sure that the volume of the water will be the same whenever I repeat with the different heights and the initial temperature of the water. And this is my table, height of the heater from the water that I change, and slash the unit is cm, and the time taken, which is measured in seconds. And the conclusion, I said that I compare the height of the heater from the water level, surface of the water, and the time taken for the water in the shallow dish to evaporate completely. That's all. So thank you very much for watching, and I hope this video helps you a lot. But if you face any difficulties, you do comment below, and please do also subscribe to my YouTube channel for more understanding in physics. Thank you very much for watching. Bye. See you in my next video.